Alright guys, welcome back to my channel, Science Made Easy, and yeah, it's time to talk some crazy science. Stick around till the end because I'm breaking down this fascinating topic into tiny easy to understand pieces. After all, that's what Science Made Easy is all about. Alright then, let's get cosmic. Imagine something that makes up almost 27% of the universe's mass. Yup, 27%, but here's the kicker. We can't see it, we can't touch it, and we can't even detect it directly. It's invisible. No light, no radiation, no nothing, and yet, this invisible something is like the universe's own glue, holding it all together. It's called dark matter, and it's one of the greatest mysteries of our time. But what exactly is dark matter? Why does it intrigue scientists so deeply? And most importantly, what's the real story here? In today's deep dive we'll explore everything scientists think they know, and don't know, about dark matter. Buckle up because by the end you might just be left with more questions than answers.
Number 1. The strange composition of the universe. To truly grasp dark matter, let's first look at the overall makeup of the universe. Believe it or not, all the stuff we can see around us, planets, stars, galaxies, even you and me, is only about 5% of the entire universe. Crazy, right? So what's the rest? Well, 68% of it is something called dark energy. This mysterious force seems to be making the universe expand faster and faster, like some cosmic repelling force that's pushing everything apart. That leaves us with 27%, the missing link, and that's dark matter. It's kind of like the hidden skeleton of the cosmos, creating gravity but not interacting with light or energy like any form of matter we know. Think of it as cosmic scaffolding we can't see but that holds everything together. If dark matter didn't exist, the universe would have no structure, galaxies would fly apart, stars would scatter, and we'd be left in a big cold dark void. Did you know this concept of dark matter is a century-old mystery? This dark matter puzzle dates back nearly 100 years. In the 1930s, Swiss astrophysicist Fritz Zwicky was observing galaxies in clusters. He noticed something odd. These galaxies were moving so quickly that there was no way they would stay together based on their visible mass alone. So Zwicky proposed the idea of Dunkelmaterie or dark matter to explain the missing mass. Then in the 1970s, astronomer Vera Rubin made a groundbreaking observation. She found that stars on the outskirts of galaxies were moving just as fast as those near the center. According to what we know about gravity, that shouldn't happen, unless there was some extra invisible mass creating the gravity to keep those stars in place. This was a game-changing moment in astronomy, bringing dark matter out of the shadows and into the spotlight.
Next up, the theories of dark matter. Let's talk about that. So, what could dark matter be exactly? Over the years, scientists have thrown a bunch of theories at the wall, hoping one would stick, with the current favorite being the WIMPs theory. And no, it's not just an insult. WIMPs, or weakly interacting massive particles, are hypothetical particles that could be floating around us right now, completely undetectable because they don't emit or absorb light. They're really sneaky.
To catch a WIMP, scientists have set up massive underground labs shielded from cosmic rays and radiation. The idea is that on rare occasions a WIMP might collide with regular matter, creating tiny signals that detectors could pick up, but so far, I guess it's been picking up crickets. This is where some scientists start to wonder, is dark matter even stranger than we thought? Another candidate for dark matter is axions. Picture axions as ultralight particles that act like a cosmic fluid flowing through space. They might even interact with magnetic fields in a weird way that would let scientists detect them indirectly. Unlike WIMPs, axions are super light, but there could be so many of them that their combined mass adds up to the gravitational pull we associate with dark matter. And here is an intriguing one: primordial black holes. These aren't the usual black holes formed by collapsing stars. They could be smaller ancient black holes that popped into existence right after the Big Bang. If there are enough of these little black holes floating around, their combined mass could account for the gravitational effects we observe. But spotting them is no easy feat. They're tiny, faint, and scattered across the cosmos. There's possibly a question in your mind right now, allow me guess. Could dark matter be gravity itself? If it is, here's your answer. Some scientists even suggest that dark matter might not be made of particles at all. Instead, they think our understanding of gravity could be, well, incomplete. Ever heard of MOND, or modified Newtonian dynamics? According to MOND, gravity might behave differently on a cosmic scale, and the effects we think are caused by dark matter could actually be from a gravitational quirk we don't fully understand yet. It's as if gravity has a secret double life. Think of it this way, if you've only ever read the first chapter of a mystery novel, you're bound to miss a few plot twists, right? That's what MOND suggests. We're still on chapter 1 of understanding gravity, and dark matter is just one of those mysteries we haven't cracked yet. As regarding our hunt for dark matter, there are some incredible detection methods. Detecting dark matter is like finding a needle in a haystack, except both the needle and the haystack are invisible, but scientists have come up with some incredibly creative methods to detect it. One of the most advanced approaches uses massive underground detectors filled with liquid xenon. Why xenon? When a particle collides with xenon atoms, it emits a tiny flash of light, which could mean we've detected dark matter, if we're lucky. Then there's gravitational lensing. Scientists study how dark matter bends light around massive objects, like galaxy clusters. Einstein's theory of general relativity first predicted this effect, and it's helped us map out dark matter across the universe. By tracking these distortions, scientists can see dark matter halos around galaxies, almost like shadows cast by something invisible. And finally, there's the Large Hadron Collider at CERN, the world's most powerful particle collider. Scientists are smashing particles together at close-to-light speeds, hoping to recreate conditions from the Big Bang. If dark matter particles can be created in these collisions, they might escape the same way they did in the universe, creating a detectable pattern of missing energy. It's kind of like trying to catch a ghost by looking for the cold spot it leaves behind. Next on the list,
what's dark matter's role in the universe? Beyond just detecting it, understanding dark matter's role could open entirely new doors. Imagine, without dark matter, galaxies might never have formed, and stars might never have ignited. This invisible framework allowed for cosmic structures to come together, influencing everything we see today. Think about it. Without dark matter, we wouldn't have galaxies, stars, or planets. There wouldn't be Earth, and there wouldn't be us. So this invisible stuff isn't just out there. It's been a silent partner in the story of everything we know.
Wait up. Could dark matter and dark energy be related? Here's a cool twist. Some scientists are even exploring a possible link between dark matter and dark energy. Imagine if dark matter and dark energy were somehow connected, two parts of a single unknown cosmic force. While it's just an idea, it could unite two of the biggest puzzles in cosmology. Think of it as two sides of a coin, with each side helping explain the other. Without wasting much of our time, what's dark matter and the future of physics? Dark matter research is on fire right now. New telescopes like the James Webb Space Telescope are letting us look deeper into space than ever before, observing early galaxies that formed when the universe was young. The upcoming Vera C. Rubin Observatory will soon start mapping the night sky in unprecedented detail, giving scientists even more insight into dark matter. Some scientists think dark matter could even hold the key to entirely new realms of physics. What if it interacts with exotic particles or forces beyond the standard model, our current best guess at particle physics? Or maybe dark matter is a bridge to hidden dimensions, or even parallel universes. This might sound like sci-fi, but it's within the realm of possibility. Dark matter could be a doorway to a deeper understanding of reality itself. Just so you know, the mystery remains. And yet, with all these theories and sophisticated methods, dark matter remains an enigma. It's like the universe itself is taunting us, reminding us that for all our advances, we're still just scratching the surface of cosmic knowledge. So what do you think? Is dark matter, particles, black holes, a gravitational quirk, or something even stranger? Drop a comment and let us know. And while you're here, don't forget to like, subscribe, and hit that notification bell. Join us next time as we dive even further into the mysteries of the cosmos, because if there's one thing the universe has in abundance, it's secrets. Stay curious and I'll see you in the next one.